Yeah, sorry all of you. Something important. So we have put in the gene for insulin in the tetracycline resistance gene, and now when the plasmid has been put inside, if we put over it tetracycline, then tetracycline resistance gene has undergone inactivation because of insertion of gene for insulin. So what will happen if we put tetracycline? The bacteria will die. The bacteria will die because tetracycline resistance gene का हमने gene for insulin डाल के insertional inactivation किया. What is that called as? Insertional inactivation. And because of insertional inactivation, the tetracycline resistance gene has now undergone insertional inactivation, and in the presence of tetracycline, the bacteria will die. In the presence of ampicillin, the bacteria will survive. Because of ampicillin resistance gene, the bacteria will survive in the presence of ampicillin, but in the presence of tetracycline, the bacteria will die because of insertional inactivation of the tetracycline resistance gene, and this means your recombination is a successful recombination. Your recombination is a successful recombination. So, once again, E. coli without PBr322, without plasmid, it will die in presence of tetracycline, it will die in presence of ampicillin. Now when we put PBr322, if the ori of the bacteria and the ori of the plasmid match each other, enzyme helps the bacterial DNA to replicate, it helps the plasmid to undergo replicate and form multiple copies. And now when we put over it ampicillin, then ampicillin resistance gene causes resistance to ampicillin. We put over it tetracycline, tetracycline resistance gene causes resistance against tetracycline, and this is called successful transformation. So ये transformation successful था. Then when we use BAN-H1 enzyme and cut the tetracycline resistance gene and put the gene of insulin, we have now caused insertional inactivation of the tetracycline resistance gene. And insertional inactivation of tetracycline resistance gene, so now if the plasmid is put inside, the bacteria will replicate, plasmid will replicate in presence of ampicillin, the bacteria will survive, which means your transformation is a successful transformation. But in presence of tetracycline, the bacteria will die because of insertional inactivation of the tetracycline resistance gene, and this is called as a successful recombination. Your recombination was a successful recombination. So इस तरह से marker gene की मदद से we can find out that transformation has taken place in the first step and recombination has taken place because of insertional inactivation. Recombination has taken place in the second step, and such marker genes help to know that the plasmid has been successfully accepted. But sir, this is a very cumbersome process. ये प्रोसेस में बहुत मेहनत है. पहले एम्पिसिलिन पे प्लेट करो, फिर टेट्रासाइक्लिन, then do insertional inactivation. So this is a very cumbersome process. बहुत मेहनत वाला process है. So scientists have found out another nice technique by using a very nice logic called as alpha galactosidase. तो कौन सा जीन से यूज किया है? अल्फा galactosidase gene. Alpha galactosidase gene, this is the bacteria and this is the plasmid in the bacteria, and here we have plasmid in the bacteria. So this is the bacterial DNA, this is the plasmid DNA, and In this bacteria, we have got its own DNA, plasmid. This plasmid has got an enzyme gene, and gene for enzyme called as alpha galactosidase. अल्फा गैलेक्टोसाइडेज नाम का ये जीन अंदर होता है, and if the ori of the bacteria and the ori of the plasmid match each other, which means the plasmid replicates along with the bacterial DNA, then now alpha galactosidase gene will produce alpha galactosidase, and इसके ऊपर एक coloring substance called as chromogenic substrate is put, and once you put the chromogenic substrate or the coloring substance, alpha galactosidase will act on the chromogenic substrate and produce an enzyme called as delphinine, and delphinine is a blue color enzyme. And sir, बैक्टीरिया की वो कॉलोनी अगर आपने अगार अगार पे कल्टीवेट की, the entire colony of the bacteria will appear blue. तो ये ब्लू कलर आ गया, and जैसे ब्लू कलर आ जाता है, it means transformation is a successful transformation, which means the plasmid ori has been recognized by the bacterial ori, and along with the bacteria, even the plasmid is replicating. So alpha galactosidase becomes an excellent marker. The chromogenic substrate becomes delphinine, and the colony of the bacteria becomes blue, which means the plasmid has been accepted, and this is called successful transformation. तो blue color क्या prove करता है? That plasmid has been accepted. This is a successful transformation. And along with it, we have another logic. इस alpha galactosidase gene के अंदर ही we have recognition sites, and we have recognition site for EcoR1. तो EcoR1 का recognition site alpha galactosidase gene में है, and we now remove this plasmid, use EcoR1, cut the alpha galactosidase gene and put in it gene for insulin. Put in gene for insulin. तो हमने alpha galactosidase gene का क्या कर दिया? We have done insertional inactivation. We have done insertional inactivation of the alpha galactosidase gene. Now when we put chromogenic substrate, because alpha galactosidase gene has undergone insertional inactivation, the alpha galactosidase gene will not produce alpha galactosidase, which means the chromogenic substrate will not become delphinine, and the color will not be blue, rather it will be colorless or white color colony is produced. And what is the meaning of white color colony? That your recombination was a successful recombination. So recombination was a successful recombination. So what is the color of the bacteria by itself? White. When we put in a plasmid, alpha galactosidase gene produces alpha galactosidase, converts chromogenic substrate into delphinine, and makes the colony become blue, which means the plasmid has been accepted. What is that blue color colony indicating? Transformation is a successful transformation. And then using EcoR1, we make a cut in the alpha galactosidase gene, put in the gene for insulin, we cause this insertional inactivation, and now when this plasmid replicates with the bacteria, alpha galactosidase gene का insertional inactivation हो गया है, so it does not produce alpha galactosidase, and chromogenic substrate does not become delphinine. And what is the color now? White. What does white color colony indicate? Recombination is a successful recombination. So this is the way vectors are used. तीन चीजें important हो गई. It should have ori matching with the bacteria. It should have recognition site. preferably one recognition site for multiple types of enzymes, and selectable markers like ampicillin resistance gene, tetracycline resistance gene, alpha galactosidase gene, which first help us to know whether transformation is successful, which means plasmid is recognized and accepted by the bacteria, and after transformation we do insertional inactivation and prove that recombination is a successful recombination. So, I hope you have understood this. बहुत ब्यूटीफुल पार्ट था, ये ध्यान से याद रखना. एंड देन वी हैव competent host for the transformation. Sir, what is a competent host? Sir, DNA by itself is soluble in protein. DNA is soluble in protein, so DNA is hydrophilic. DNA is hydrophilic and cell membrane is made up of lipids. तो ये सब जो bacterial cell membrane है, this is made of lipids, and lipids are lipophilic or lipid soluble. In other words, they are hydrophobic. So DNA is hydrophilic and cell membrane is hydrophobic or lipophilic. So the challenge is how to put the DNA inside through the hydrophobic cell membrane. If you are able to put it inside, then now the cell is called as a competent host cell. अगर DNA अंदर चला गया, then it is called as a competent host cell. तो समझो प्लाज्मिड हमें इंसर्ट करना है, if we are able to insert the plasmid, then it is called as a competent host cell. तो समझो E. coli के अंदर हमें प्लाज्मिड को इंट्रोड्यूस करना है. अभी plasmid is DNA and we want to introduce inside, so this becomes a competent host cell. How is this done? How is the plasmid inserted inside? सबसे पहले one technique we can do is treat the bacteria with a divalent cation such as calcium. Calcium makes pores in the cell wall. तो सेल के ऊपर कैल्शियम आयंस पास किए जाते हैं, इट विल मेक पोर्स इन द सेल वॉल. सेल वॉल के अंदर होल्स बनने लगेंगे एंड देन यू ट्रीट द सेल विद कैल्शियम एंड देन एक्सपोज द सेल बाय पुटिंग इट ऑन आइस, followed by placing them at 42 degrees Celsius heat shock and then putting them back again on ice. This will ensure the bacteria takes up the recombinant DNA. इसे थर्मल साइक्लिंग कहते हैं. तो पहले हमने कैल्शियम डाला और होल्स बना दिए एंड देन वी ट्रीट द सेल टू आइस. आइस में 0 डिग्री सेल्सियस and then follow it by 42 degrees Celsius, which is a heat shock, and heat shock दिया जाता है and again put it on ice. तो वापस ice heat shock ice will make the pores become enlarged and the plasmid enters inside, and that means E. coli now becomes a competent cell or a competent host. तो competent host बन जाता है. This is one way. Another way of treating it is micro injection, in which recombinant DNA is directly injected into the nucleus of an animal cell. तो ये एक एनिमल सेल है और उसके न्यूक्लियस के अंदर समझो आपको डीएनए डालना है, तो दिस इज अ नीडल, दिस इज अ सिरिंज एंड पीछे पिस्टन होता है. Take the DNA or the plasmid, and this plasmid is now there in the syringe. उसके अंदर distilled water भरा जाता है and the needle is allowed to penetrate into the nucleus. The piston is pushed और जैसे piston push करेंगे, distilled water along with the plasmid will directly enter into the nucleus और nucleus of animal cells के अंदर इस तरह से DNA या plasmid को इंट्रोड्यूस किया जाता है. This is called as micro injection. तो ये माइक्रो इंजेक्शन से एनिमल सेल में डीएनए पुश किया जाता है. समझो इट इज अ प्लांट सेल. समझो ये प्लांट सेल है. देन प्लांट सेल का एक प्रॉब्लम है. सेल मेम्ब्रेन के साथ देयर इज अ स्ट्रिक्ट सेल वॉल. तो सेल वॉल भी है एंड सेल वॉल को पेनिट्रेट करके, सेल मेम्ब्रेन को पेनिट्रेट करके, न्यूक्लियर मेम्ब्रेन को पेनिट्रेट करके प्लाज्मिड अंदर पहुंचाना है. For that, we use something called as a gene gun, and that technique is called as biolistics. So, biolistics or gene gun is used, जिसके अंदर एक literal gun होती है with a nozzle and पीछे है trigger and trigger के साथ ये उसका handle. And so इस nozzle के अंदर we put in a small particle of gold or tungsten, a high velocity particle of gold or tungsten coated with DNA. तो gold या tungsten का particle लिया जाता है. You done it in chemistry. What is the charge of gold and tungsten? They are highly positively charged. And what is the charge of DNA? DNA is negatively charged. So negatively charged DNA winds around the gold particle or winds around the tungsten particle, and that is loaded in the needle, and then the trigger is pulled and this high velocity particle passes through cell wall, passes through cell membrane, passes through nuclear membrane, and here we have the gold or tungsten particle with the DNA in it. And so plant cell में इस तरह से DNA को इंजेक्ट किया जाता है. What is this called as biolistics और gene gun. तो एनिमल सेल्स के लिए क्या यूज किया जाता है? माइक्रो इंजेक्शन. एंड प्लांट सेल्स के लिए क्या यूज किया जाता है? बायोलिस्टिक्स और जीन गन. And one more method, use disarm pathogen vectors which are allowed to infect the cell and transfer the recombinant DNA into the host. तो सर यहाँ होस्ट सेल के अंदर आप एक बैक्टीरियोफाज यूज करो एंड बैक्टीरियोफाज के अंदर से उसका खुद का डीएनए निकाल दो. रिमूव द डीएनए ऑफ द बैक्टीरियोफाज, पुट इन द प्लाज्मिड, and the bacteriophage will make a hole in the bacterial cell wall and put the plasmid inside, and plasmid is nicely introduced into the host cell by using a bacteriophage which is called as a disarm pathogen vector. So sir, treat with calcium, ice, heat, ice, one method, or use a micro injection, or use a biolistic gene gun, or use a disarm pathogen vector, in other words a bacteriophage, and introduce DNA into the host cell. What is this called as? Making the host cell become competent. तो ये competent host cell बन जाता है. Now that we have done everything, we want to manufacture this product on a large scale level. तो आपने समझो जीन फॉर इंसुलिन यहां पर डाल दिया प्लाज्मिड के अंदर, एंड नाउ जीन फॉर इंसुलिन शुड प्रोड्यूस अ लार्ज क्वांटिटी ऑफ इंसुलिन. तो अगार अगार जेल पे तो थोड़ा सा इंसुलिन बनेगा, इट इज गॉट अ स्मॉल क्वांटिटी. समझो यू वांट टू मेक अ लार्ज क्वांटिटी ऑफ इंसुलिन, देन नाउ व्हाट विल यू गो इन फॉर? सर वी विल गो इन फॉर अ टेक्निक व्हिच इज कॉल्ड एज अ बायोरिएक्टर. और बायोरिएक्टर्स के अंदर कंटिन्यूअस कल्चर सिस्टम से लार्ज बायोमास इज ऑब्टेन्ड. एंड सर व्हाट इज अ बायोरिएक्टर? तो एक स्टेनलेस स्टील का बड़ा सा इंस्ट्रूमेंट होता है 20 फीट टॉल स्टेनलेस स्टील इंस्ट्रूमेंट. उसके अंदर सर वी हैव दिस अरेंजमेंट. सबसे पहले एक छोटा सा होल होता है जिसमें वी पुट स्टीम for sterilization. तो उसके अंदर steam पास की जाती है. Steam will go inside. Steam 100 degrees Celsius goes inside. Most microorganisms, or rather all microorganisms, at a temperature of 60 to 70 degrees Celsius die. So when the steam will pass inside, the steam will neutralize and kill all the microorganisms. That means your bioreactor has now become sterilized. पूरा sterilized हो गया है. And then we introduce in it a nutrition medium. Nutrition medium अंदर सुक्रोज डाला जाता है. And सुक्रोज के साथ अमाइनो एसिड्स डालते हैं, विटामिन्स डालते हैं, मिनरल्स डालते हैं, एंड उसके अंदर फिर डालते हैं द कॉम्पिटेंट होस्ट सेल E. coli which has got plasmid with the recombinant gene for insulin has been put inside. Now using the sucrose, the bacteria multiplies fast. Bacteria love sugar, they multiply fast in the presence of sugar, and bacteria rapidly replicate, and यहाँ नीचे से sterile air डाली जाती है, and sterile air goes into the bioreactor, and there is a motor which is connected to flat bladed impellers. तो इम्पेलर्स यानी फैन के ब्लेड्स होते हैं, वैसी ब्लेड्स होती है, एंड मोटर की मदद से these blades keep on rotating and the entire sucrose solution keeps on mixing with each other. और सुक्रोज के अंदर E. coli भी मिक्स होता है, एंड E. coli के अंदर प्लाज्मिड रेप्लिकेट होता है, एंड प्लाज्मिड के साथ जीन फॉर इंसुलिन रेप्लिकेट होता है, एंड दैट जीन फॉर इंसुलिन undergoes transcription and translation to produce a huge quantity of insulin. और इस तरह से बहुत सारा इंसुलिन बनाया जाता है. This is called as an upstream process. इसे क्या कहते हैं? Upstream process by which insulin is synthesized. And once insulin is synthesized by the upstream process, now we remove all the sucrose, and sucrose के साथ E. coli bacteria बाहर आता है, and along with the E. coli bacteria, inside the bacteria there is insulin. So these bacteria are now allowed to break. बैक्टीरिया को तोड़ा जाता है. Bacteria are broken down, and bacteria are broken down with the help of a chemical called as endolysine. And endolysine से bacteria are broken down, and then using endolysine, when bacteria are broken, उसमें से insulin मिलता है. This insulin is separated, it is purified, and it is put with preservatives into a vial, and vial के अंदर इंसुलिन को सेपरेट, प्यूरिफाई एंड प्रिजर्वेटिव के साथ डाला जाता है. That is called as a downstream process. So what was making of insulin called as an upstream process? What is collection of insulin, purification and mixing it with preservatives called as a downstream process? And then this product is available in the market for people. Every day 3 million children take human insulin or humulin, which has been prepared by this beautiful technology called as DNA recombinant technology. So today we have done a beautiful topic, extremely important from the NEET point of view. Please study this well. Any doubts we will take care of in the Zoom session. Take care. God bless you. Bye-bye.